Hi everyone, welcome to RoshChem summary videos. In this video, I'm summarizing the lesson properties of water. Okay, so we'll see some important properties of water. The first one, water has a higher melting and boiling temperature compared with other substances with similar number of electrons. The main reason for this is water has very strong hydrogen bonds when you compare with other substances with similar number of electrons. If you take a sample of water, like each water molecule is surrounded by four other water molecules using hydrogen bonds. The next property is water expands on freezing, or else the ice has a greater volume than liquid water. The reason is if you take the structure of ice, it has a special structure called open hexagonal crystalline structure. So this structure is held by, again, hydrogen bonds. In this structure, the water molecules are further apart, increasing the volume. So that's why we say ice expands on freezing. So therefore, the density of ice is lower than liquid water. The third property is water has a higher specific heat capacity. So what is this specific heat capacity? So it is the amount of energy needed to increase the temperature of 1 gram of a substance by 1 degrees. So when it comes to water, the water specific heat capacity is higher when you compare with other substances. The reason is water has strong hydrogen bonds. Therefore, you need to give large amount of energy to increase the water's temperature. And the fourth property is water also has higher latent heat values. So what are these latent heat values? The latent heat is the amount of energy needed to change the state of a substance, either from solid to liquid or from liquid to a gas. So water's latent heat values are also higher. That's again due to the strong hydrogen bonds. So due to these strong hydrogen bonds, we need to give large amount of energy to break them. Okay, we'll look at some calculations. The calculations involved in the equation Q equals to mc delta T. So in this equation, Q is the heat energy, M is the mass, C is the specific heat capacity, and delta T is the difference in temperature or the change in temperature. So if mass is given in grams, you get Q in joules. If I use mass in kilograms, the unit of Q will be kilojoules. Okay, we'll look at this question here. What is the amount of energy absorbed in kilojoules when 10 grams of water was heated from 20 to boiling point? So, the boiling point of water is 100 degrees. Okay, so I use Q equals to mc delta T. So mass is what? 10 grams. So C for water, the specific heat capacity of water is 4.18. You can find this in your VCE Chemistry data book. And then the change in temperature, the initial one is 20, going to boiling point, which is 100. Therefore, the change in temperature is 100 minus 20. So you get 3,344 joules. So why joules? Because the mass was in grams. So I get my answer in joules. So after that, to make it kilojoules, I divide by 1000. So I get then 3.44 kilojoules. Okay, we'll look at another calculation now. So this calculation involves Q equals to NL. So the L is the latent heat. So Q is again the heat energy. N is the number of moles here. In the previous one, it was the mass. Now it is the number of moles, and L is the latent heat. So we have latent heat of fusion, which is called LF, and also we have latent heat of vaporization. So latent heat of fusion is how much of energy we should give to change the 1 mole of substance from solid to a liquid. If it is LV, which means how much of energy we give to change the 1 mole of substance from a liquid to a gas. Okay, now we look at this question here. So 5 kilojoules of heat energy was absorbed by an unknown mass of ice, which was at 0 degrees during its melting. So ice is melting at 0 degrees. The amount of energy absorbed is 5 kilojoules. The mass of ice melted was, so we don't know what is the mass of ice melted, but it's given the LF of water or ice, it's 6 kilojoules per mole. So which means if you have 1 mole of ice, it requires 6 kilojoules. So we write the equation Q equals to NLF. So then I can find N equals to Q divided by the latent heat of fusion value here, kilojoules. So here Q is the amount of kilojoules, 5 kilojoules, divided by the latent heat value, which is 6 kilojoules per mole. So then I get 0.833 moles. So this is the amount of ice in moles. It's asked in the mass. So mass equals to what? Moles times the molar mass. So molar mass of water is 18. So you get 15 grams then. Okay, now we'll look at another question which involves both the equations, Q equals to NL and also Q equals to MC delta T. So how much water at 60 degrees is needed to just melt 180 grams of ice at 0 degrees? So what happens here, you have hot water which is at 60 degrees and you put into ice is at 0 degrees. So what will happen when you put hot water into ice? The ice will melt. So it's asking how much of water was needed for that. So I can, in this question, I can assume that all the energy released by hot water will be gained by ice for melting and no energy lost. So I write energy released by hot water, which is at 60 degrees, equals to energy gained by ice for melting. So energy gained by ice, right? For ice, I can use the latent heat equation, Q equals to NL. So this is the moles. So it is Q equals to energy gained by ice. So Q equals to NL. So this is the mole. So how do we find moles? The mass is given, mass over molar mass. Then times by L. So LF, because it's melting, so I use LF value, which is 6 kilojoules per mole. So you get then 60 kilojoules. So this is the energy gained by ice for melting. So then I can say the same amount of energy is released by hot water. Energy released by hot water at 60 degrees is also then same. For hot water, I can use the equation Q equals to MC delta T because its temperature is now changing. It was at 60 degrees. Now when you put into melting ice, its temperature will drop to 0 degrees. So now there's a delta T here. So I can use the equation Q equals to MC delta T. So then Q is 60. So I don't know the mass of hot water. So I know water's specific heat capacity, the C value here is 4.18 and delta T is the difference in temperature, which is 60 minus 0. So that gives you M. So you will get this M in kilograms. Why? It was 60 kilojoules. So I said before, if it is kilojoules, the mass I will get in kilograms. Then after that, we can convert into grams by multiplying by 1000. So this way I get 239 grams. Okay, so that's the end of this lesson. So now please do questions from RoshChem study guide. You can find the questions and summary notes on pages 77 to 81. And thanks for watching my video. If you need any further information, please visit our website www.roshchem.com. I will see you in another video. Bye.